Hi students. In this lecture, I am going to discuss relation between angular momentum and torque. Let us see. Consider a rigid body. So taking a rigid body which is free to rotate about a fixed axis. Let us consider one point mass in that body. Let us say its position vector is r bar from axis of rotation, and suppose momentum is p bar, momentum p bar. Then you can see angular momentum, or you can say it is now ith particle, then Ri bar, position vector of ith particle, cross Pi bar. This is angular momentum, right? Like this, we have to consider all particles. That means we have taken out summation of all these things. So that is now angular momentum of that body, right? Now differentiate this. Now it is dl bar by dt. dl bar by dt, that is equal to summation. Let us differentiate position vector by keeping the other vector constant. It is now dri bar by dt cross pi bar. Now take position vector constant, differentiate momentum vector dpi bar by dt. Now see what we get. dr bar by dt, that is velocity vector, right? Velocity vector and momentum vector both are in same direction, because p bar equal to m into v bar, right? So both are in the same direction. That means if you take cross product, this becomes 0 because angle is 0. Remaining is now sigma ri bar cross derivative of momentum vector with respect to time, and this gives net force, right? According to Newton's second law, net force on a particle is equal to rate of change of linear momentum with respect to time. So now taking that here, it is Ri bar cross. This is net force on ith particle. Okay. So you can see Ri bar cross Fi bar. This is the torque on ith particle. Like this, taking torque on each and every particle, then taking sum of all these things. This is now net torque. This is now net torque. That means net torque is equal to dl bar by dt. Okay. And in this torque, we are having one is a torque due to external forces and torque due to internal forces. Sorry, it is internal forces. It is due to internal forces. Due to internal forces. And we are knowing that sum of the torques due to internal forces, that becomes 0. That means now this is equal to, so net torque is nothing but net external torque, because net internal torque becomes 0. So net external torque or simply net torque is equal to dl bar by dt. Okay. So it is just like when you compare with Newton's second law, net force is equal to Net force equal to rate of change of linear momentum with respect to time. So here net torque equal to rate of change of angular momentum with respect to time. Okay, let us now solve problems. Let's see the question given. Two particles of masses m1 and m2 are joined by a light rigid rod of length r. The system rotates at an angular speed omega about an axis through the center of the system. Here center of system means center of mass of the system and perpendicular to the rod. Show that the angular momentum of the system is L equal to mu r square omega, where mu is the reduced mass of the system. Okay, let us see how to calculate. So we are taking now 2 point masses. 2 point masses m1, m2. Separation between them is r. Now this system is rotating about center of mass. Let us take now this is center of mass. Distance of m1 from center of mass, take it as r1. Distance of m2 from center of mass, it is r. Okay, let us see. And this is given now angular speed omega. Then for this particle L value, so what we can write? It is m1 r1 square omega angular momentum of this particle, right? Next, for this one, m2 r2 square omega. Okay, because simply what we can say here, m into speed equal to r omega, right? So r1 omega speed into r, right? This is now angular momentum of the system about center of mass. And we are knowing that r1 equal to m2r by m1 plus m2, r2 equal to m1r by m1 plus m2. This is what we have learned in center of mass, right? Substitute these values in this one. It is m1 in the place of r1 square, m2r by m1 plus m2 whole square. I take omega outside plus m2 into in the place of r2, it is m1r by m1 plus m2 whole square. So I'm taking omega completely outside. Okay, now simplify this. So here what I can do is I'm taking here m1 outside, m1. We're having m2 square. I'm taking one m2 outside. Here m1 plus m2 whole square, and here also m1 plus m2 whole square. I am taking only one outside, that is m1 plus m2. Okay. Now see what else left. Here m2 over. Remaining is now m2 is left. Here having r square and r square. And that also you can take outside. R square omega. Okay. See what else left. Here m2 is left. m2 by m1 plus m2. Here m1 is left. So m1 by m1 plus m2. That total becomes now 1, right? This is now mu r square omega, where mu is known as reduced mass. This also we have learned in center of mass, right? So simply calculating I1 omega 1 plus I2 omega 2. Okay. See next one. The potential energy of a particle of mass m at a distance r from a fixed point O is given by kr square by 2. K is a positive constant of appropriate dimensions. This particle is moving in a circular orbit of radius r about the point O. If v is the speed of the particle and L is the magnitude of its angular momentum about O, which of the following statements are true? Asked in advance 2018. So given potential energy kr square by 2. So now we have to calculate what is the speed and angular momentum about O, right? Let us see now how to start the problem. So first write down the given condition. Potential energy is given as kr square by 2, right? That is a function given kr square by 2. Next, we have to get a speed, right? It is a following now circular orbit of radius r. Okay. First of all, focus now how to get centripetal force. Since it is now following circular orbit or circular path, there must be centripetal force, right? And here potential energy given, the corresponding force is now conservative force. And we have learned in work energy power relation between conservative force and potential energy. That is minus du by dr, right? So here notation is given as V. Okay. Let us focus the modulus of that force, modulus value. Then see what we get derivative. 2r, 2 gets cancelled. It is now kr, okay, modulus value. R square derivative is 2r, 2 gets cancelled, kr. This is now centripetal force, which is equal to mass into centripetal acceleration. That is v squared by r. Okay. Now from this, we can say v square or v value. It is a k by m under root k by m under root r square. It is r. Now it is given circular orbit of radius capital R. That means we have taken the place of a small r. It is a capital R. That means option B is matched, right? Next, calculation of angular momentum about center of circle, right? So L equal to m into v value k by m into r m into v into r, because this is r bar and p bar is along the tangent. Between these two angles is now 90. So we are taking actually r bar cross p bar, and between those two angles is 90. So directly r into p. R means here radius. P means m into v. Okay. That means, so which option is taking m inside? It becomes root mk into r square, right? So option C. So correct options are B and C, right? Very simple one. Let us see next one. Let's see what is given here. A particle of mass 0.2 kg is initially at rest in the xy plane at a point x equal to minus L, y equal to minus h. That means it is in third quadrant. L is a 10 meter and h is 1 meter. The particle is accelerated at time t equal to 0 with a constant acceleration 10 meter per second square along the positive x direction. Its angular momentum and torque with respect to the origin in SI units given by L bar and tau bar respectively. Then choose which of the following statements are correct. SAS 2021 advance. See options given. 20 equal to seconds. What is the position vector? Next, we have to calculate torque, angular momentum, right? Let us see. So first make the diagram for the given data. So it is moving in XY plane. XY plane. It was initially at rest. It was initially at rest. This is now third quadrant corresponding to minus L minus H. Okay. And given L value 10 meter, H value 1 meter, mass 0.2 kg. Right. Now see options. The particle arrives at the point at t equal 2 seconds. And given one more thing, acceleration, right? Which is a constant that is 10 meter per second square along positive x-axis. Okay. Then see what happens. It was initially at rest. Therefore, displacement equal to half a t square 2 square, right? Displacement is now 20 meter. L value given 10. So this is from origin, right? This is minus 10, isn't it? That means now it will be at L comma minus H because L value 10. 10 plus 10, 20. This is 20 at this location. It is given now L comma minus H. So first option is match. Okay. Now verify second option. At this instant, what is a torque? So torque equal to, we are taking actually net torque because acceleration given, mass into acceleration is net force and net force equal to 2, right? R bar cross F bar. Taking R bar cross F bar. Okay. Then see what we get. Our first focus here magnitude F into R, F value 10 into 0.2, that is 2. F into distance. We are calculating now. It is about passes through the point at torque. So we are calculating now torque about origin. See the question once. Torque given about which point? Both are given now about origin, right? With respect to origin. So we have to focus now. Force is along positive x-axis. Distance, perpendicular distance, right? Imagine line passing through a point parallel to force. So separation means it is equal to h. Okay. And h value how much? It is 1. So 2 into 1. That is now 2. This is magnitude. And you can see this is now R bar. Okay. This is R bar and this is F bar. R bar cross F bar. If you curl fingers of right hand, keeping on R bar towards F bar, thumb will be outwards. Outwards means it is along positive z axis. It is now k cap. Okay. That means option B is match. Next. Next, we are focusing angular momentum. Again, same thing here. L bar equal to R bar. Again, I'm taking directly modulus values. Right. First focus M into V value starting from rest. So V equal to A into T. A value 10. T value asking after 2 seconds, right? So it is a 2. So V value how much? 20. Okay. So M into V into M into V into R. Perpendicular distance. See, momentum vector, it is now again in the same direction that it is in the direction of F bar. Okay. That means that distance is again equal to 1. Right. So M into V into R. Means it is actually R sine theta, right? R sine theta. This is now, it is equal to 4. Direction part. Again, R bar cross P bar. Here, direction of F bar, direction of P bar, both are same. That means it is again K cap. Okay. That means option C is also correct. Now coming to option D. When it is at origin, in fact, torque. See torque how much? It will be again same, right? Because F bar, no change in that. It's a perpendicular distance, no change in that. So value will be, it is 2k cap. Means at any position, at any instant, torque will be same, no change in that. Okay. So it must be equal to how much? 2k cap. Okay. But what is given here? K cap. That means correct options are A, B, and C. Okay.